today. I'd like to thank you all for joining us. We're really glad to have you all with us. And today we're going to have a webinar that examines the opportunity to streamline your site operations and improve financial performance by insourcing many components of site survey using affordable and easy to use tech in the field, supported by a collaborative workflow. So what I'm hoping is, there we go, that's kind of working. So construction's a business of tight margins. A misplaced trench, a slab poured at the wrong elevation, a retaining wall stake 2 meters off. These aren't just mistakes in the field, they're expensive mistakes. And rework eats into profit. Delays ripple downstream, and waiting around for a surveyor isn't always an option. And here's the shift that's happening on job sites. More subcontractors are closing the survey gap by picking up RTK GNSS receivers and doing positioning work in-house. Not to replace their surveyor, but to reduce daily dependence on them. Routine checks, stakeouts and as-builts that used to require scheduling a third party can now be done by your own crew on your own time with equipment that's affordable and easy to use. Today, we're going to explore that. And as always, we've invited a special guest to bring this to life with real-world experience. So today we're joined by Philip Wilson from environmental services company Trilogy Consulting in South Australia. And Trilogy do a lot of work in contaminated site assessment and rely on Emlid RTK GNSS solutions to keep construction projects moving forward, or I should probably say to keep earth-moving projects moving forward when sites throw up a challenge. And we'll hear more from Philip later on about all of that. First, though, I'm going to give you some, what do we call this stuff these days? AI trash or something? I can't remember what they call that stuff, but I made one up. And what I want to do here is ask a provocative question. Why is the most expensive asset on your site a machine that isn't moving? With medium to large excavators sitting idle, costing anywhere from 125 to 400 bucks an hour, an idle crew costing from 25 to 75 bucks an hour, equipment downtime and crew downtime really impact on costs. It's easy to see how project profit lines can just evaporate if the project is delayed, waiting on specialized survey equipment and contractors to get that part of a site moving again. Construction projects are often delayed by slow access to accurate information, rather than being delayed by a lack of accuracy in itself. So as we've discussed, delays cost money. You know what else costs money? Rework. Correcting a surveying error after concrete is poured or utilities are buried costs 10 to 100 times as much as preventing it initially. Today, we're going to explore Emlid's GNSS ecosystem, which solves this by enabling non-surveyor crews to handle routine spatial tasks with survey-grade accuracy. Emlid receivers offer centimetre-level RTK accuracy and don't require heavy training. And we'll get into how that's possible shortly. Before we do, however, I want to invite the audience to have an opportunity to share their story. We've got a little poll here, and it prompts our audience to share their experience with any delays or idle time that they may have experienced with their sites that they've been on. I'd like to encourage you all to participate in this if you've got this experience, and keep in mind that there is an opportunity to win a merch prize pack at the end of it. All right, okay, well, the odds are that someone's, oh, there we go, we've got 2 respondents. All right, 3 respondents. Okay, so this prize pack's getting a little bit more competitive. So I guess what we're seeing, though, is that, you know, the majority of our poll respondents so far have got some experience with idle time while sites are waiting for set out or volume surveys or, you know, some other form of survey verification. So now we know a little bit. Sorry, I just realized you guys couldn't see the results. So there you go, that's the results. So, you know, there's at least one user that's experienced more than 20 hours of idle time a month. And like those costs really stack up pretty quickly. Anyway, now we know a little bit more about the scale of this challenge. Let's reflect on some difficult dilemmas that can be faced by construction project managers when seeking to keep the survey tasks flowing. So, you know, if you want to get GPS gear for your site, you're faced with this difficult dilemma. Typically there were two choices and neither of them were very good. Buy an expensive professional RTK GNSS receiver or work with something really cheap, which does not offer the horizontal and vertical accuracy necessary for a construction site. So, that leads to a third choice, which is to engage a professional contract surveyor. And depending on the scale of the project, that surveyor may not always be on site when really needed. And again, they're not particularly cheap. And this is where Emlid come in. Emlid offers a centimetre level RTK accuracy, and as you can see from these prices, it doesn't require large capital investments or heavy training to get your own equipment onto site. Not only does Emlid offer affordable hardware, it offers a real-time collaboration between the field and the office. So in the field, the Emlid Flow app for iOS and Android simplifies complex GNSS work with visual guided steps for tasks like stakeout, cut fill checks, and as-built capture. No complicated setup or survey experience needed. It's just a phone in your pocket that's easy to use. And performing routine GNSS work in-house eliminates delays, reduces schedule risks without sacrificing precision. And this keeps surveyors essential for specialised tasks and keeps the site moving in the meantime. So one of the big things is the inertial measurement units that are embedded into all of the Emlid GNSS receivers. So the operator no longer needs to wait for a bubble level to settle. They no longer need to stand directly over a mark, as you can see in this image on the left-hand side. That's me, and it was difficult and challenging in that environment, in that loose soil, to get that bubble to level up. And actually, it's an interesting story because if you zoom out on that picture, I'm standing on the side of a diversion drain and I'm staking out the center line of the drain. So this is a site where they've gone ahead and constructed without having a surveyor on site. And it's a perfect example of where not having a surveyor or at least the equipment to be able to stake it out for yourself on site has led to, effectively some rework. And on this site, they did end up buying some Emlid hardware, and the Enviro on site was using that to help keep the earthworks moving and to help keeping them building to design. So one of the other benefits with the tilt compensation is that they can measure accurately, even with the pole tilted up to a significant angle. I believe Emlid claim accurate tilt compensation up to 60 degrees. And what that does is it saves 50% of the time per measurement on average. And of course, it also means that you can take measurements on points that aren't safe to stand directly over, like excavations and that sort of stuff. And of course, tilt compensation is now embedded in every Emlid model. So the other benefit of the Emlid receivers are that they're really adaptable because they use internet-based corrections for an incredibly simple and user experience. It's great for urban areas to be able to connect to AusCores or SmartNet or all-day RTK or other N-trip corrections. And the AusCores one is a free Australian government correction. But they also, at least the RS series receivers, contain embedded LoRa radios for remote base and rover setups in areas where you don't have mobile coverage, and UHF frequencies to connect with legacy third-party base stations. So if there's a Trimble that's already set up on site and broadcasting in trim talk, the Emlid receivers can consume that correction to deliver accuracy without you having to set up your own base. All right, here's another chance for people to get in the draw to win some merch. Does your business all have internal DIY survey capability always on site? So you don't have to have a surveyor always on site, but if you've got some gear that someone can sort of know how to use to be able to take a design and translate that onto the landscape. All right, we've got a couple of people answered so far. And if you scroll down on that question, there's also the opportunity, if you don't have that stuff, to flag any barriers that might limit you from having your own DIY survey capability available on your site. So I've got 6 people have responded to the first question, 7 now, and 4 have responded to the next. Because we've got a fair bit of stuff to get through, I've now got, there we go. I'm now going to end the poll and share the results. So we've got 43% of our viewers do not have access to gear always on site. And it seems to be a combination of predominantly cost, skills, and aversion to risk that are some of the barriers. And I can see there's one person that's even flagged that all of those elements are limiting their opportunity to have a survey capacity always available on site. All right, moving right along. The next slide talks about the sorts of tasks that that construction teams can do with confidence without necessarily being surveyors. So modern GNSS puts survey grade accuracy directly in the hands of construction teams because it's so affordable and simple to use. With guided workflows and built-in checks, crews can handle layout, verification, and documentation themselves without cutting corners. And the key isn't doing everything in-house. It's knowing which tasks you can safely own and when a licensed surveyor still needs to step in. And we'll expand on that a little bit later. In the meantime, here's some examples of some of the GNSS tasks construction teams can confidently handle on their own. So QA and QC checks. So being able to import a design and as a supervisor, walk around on site and confirm that things are aligned correctly. We had one customer that poured a concrete slab 20 centimeters out, and unfortunately that put the concrete slab too close to the neighbour's property. And there was a heck of a lot of rework in that because, of course, you know, when you're pouring a slab, you're not just pouring concrete, you're burying all of the plumbing and other utilities that have been placed into that footprint prior to the concrete being poured. This was for a residential property. So, you know, big mistake, very easy to avoid. And, you know, being able to check on that yourself and know where things are relative to other things can reduce some of that risk. Another great example is doing checks on grades and cut fill. So project managers can drag and drop DXF or LandXML design files into the browser, and that instantly syncs to the field technician's mobile device. So you can see on the right-hand side, there's an image showing a surface that's been developed on a laptop. So a three-dimensional surface, a design surface. And then the operator out in the field clicks on that surface, says stake it out, and it's telling him how far he needs to cut or fill to bring the level of that landscape to the surface. And I think one of the big benefits here is avoiding over-excavation, because over-excavation is expensive and it's really easy to do if you're just doing cut by eye. And, you know, once you disturb that ground, you've got to go back and refill it and compact it, it starts to get expensive. Another example of things that construction crews can do is setting out the design onto the landscape and marking it for earth movers to engage with themselves. So in this interface, you can see that we've got a phone, and the phone has got a three-dimensional surface and a whole bunch of strings from AutoCAD showing the alignment of, you know, an embankment with, you know, toe of embankment, top of embankment, diversion drains down the bottom side of that. So it becomes quite easy for construction managers, project managers, to be able to drag and drop the DXF and LandXML files into Emlid Flow 360 on their browser. And when they do, it instantly syncs to the field technician's mobile device. I think we've got some slides on that later on. And then, of course, there's as-built and utility digitalization or documentation, basically doing your ASCONs. So you can pick up what has been constructed before it gets buried, and that makes it so much easier for people to know where utilities are and how far down they are before the utilities are buried in the first place. And that makes the job of underground service location contractors like Chris so much easier, because then they have precise information to work with, and they're not relying on, interpreting ground penetrating radar or other nuanced information sources to identify the location of some of those utilities. In this image, you can see the Emlid Flow mobile app, and this guy's out there staking cut and fill, and that could easily be done by a foreman. So it's not just the guy going out and marking it out for the earth movers. It can also be a foreman or a supervisor that's wandering around and just checking on stuff, and being able to do that relatively easily without waiting for the specialists. And in fact, we've got a major international construction company that's active in probably every state in Australia on major, infrastructure builds like highways and interchanges, and they're using Emlid gear quite a lot. So one of the other things that you can do is topographic surveys. So in this example, someone's gone out to a landscape and they've just collected a network of points. And from that network of points, they can develop like an elevation data surface quite easily. And if anyone would like to know more about that, we've actually got a DIY cheat sheet on how to do that with open source GIS software. So once you've collected the points, how to convert that into a surface. If anyone wants to know more about that, hit our team up and we'll be happy to share that information with you. And the Emlid gear is also really fantastic at supporting drone mapping surveys by providing a reference point for RTK drones and for laying out ground control points and quality checkpoints. And in this example, you can see a before and after where a tailing storage facility embankment has been cut away and used to cap the tailing storage facility. And you can see some of the diversion drain works off to the left-hand side of that image. But in this analysis, the drone data and the volumetric parcel are able to be used together to calculate the change in volume on that site to validate the invoicing that has come from the contractor that's shifting all of the dirt around and is getting paid by the cubic meter. So you can also do really simple volume calculations using Emlid. So in this example, which is kind of a bit of a made-up example, we went down to the local playground, and in this example, the hypothetical scenario is that we need to top up the sand in the playground. And to do that, we need to know, what's the area of the playground, and then we can think about how much sand needs to go into it and very quickly get the volume right. So we talked before about eyeballing earth moving cuts and over excavating. An interesting statistic that I came across is that eyeballed volumes can often be out by up to 40%. And if that's the case, that can really quickly erode project profit margins. So the example that I came across was quite specific, where the site manager had estimated that there was 5,000 cubic meters of cover that needed to be shifted, but in reality, it was around 7,000 cubic meters. So that's a 40% overrun right there. And you can imagine if you'd estimated 5,000, but then you're paying for 7,000 cubic, that's 2,000 cubic meters of extra material that you've got to shift and pay to get shifted, but you're not getting paid to shift it. So that's a huge dent to the project bottom line. So in this case, however, what we're doing is we've set the auto collect feature, and I'm just basically tracing the outline of the playground, and it's collecting a point automatically every 50 centimeters. It's dropping all of those points onto the map, and we can then convert those points into a line, and then convert that line into a polygon by closing the line. And as soon as you close the line, you can see the clothesline statistics in this screen where it's where it's showing that the area is 159 square meters. And let's just say that we wanted to drop 10 centimeters of extra sand into that. We know that we're going to need 15.9 cubic meters of sand. So, area times 0.1 of a meter to have the right volume of material to do that job. So reflecting back on the affordability of the Emlid hardware and the fact that there's no ongoing firmware maintenance costs, Emlid provide all of that free for the life of the product. And the basic version of the software is free. And if you want to go to the advanced version, you're still only talking about $375 a year. You can see from these prices, it doesn't require large capital investments, and you can already see from the examples that we've given that it doesn't require heavy training either. So now, again, it's an opportunity to hear from the audience, how much are your construction sites spending on external survey fees? Or how much did you spend on that before you built your own DIY capability? Okay, I also just want to welcome Craig Sandy, who's the Surveyor General for Victoria, who's just joined the poll. How are you going, Craig? You'll be pleased to know we've got a slide later in the presentation reinforcing that we don't want people that are doing DIY engineering surveying moving boundary pegs and the like around. Great, okay. So you can see that, oh, you can't yet. I need to end the poll. We're going to end the poll now and share the results. Okay, so we can see that from some of our viewers, there's a range of expenditures. But if you think about the fact that getting into Emlid costs, from $4,000, it's very easy to get a rapid return on your investment. Alrighty-o. So what we're going to do now is talk through a little bit more of that office to field to office real-time collaboration that Emlid enables. So, we talked about the fact that, the affordability and simplicity of the user experience allows construction teams to get their hands directly on modern GNSS hardware that offers, GNSS survey grade accuracy. And with guided workflows and built-in checks, construction crews can do a lot of work themselves without cutting corners. And again, I'll say it again, the key isn't doing everything in-house. It's about knowing which tasks you can safely own and when a licensed surveyor still needs to step in. So let's have a closer look at how this office to field to office workflow might take place. So in this slide, we've got an image of a landscape, and it's adjacent to an existing tailing storage facility, which is now full, and the client needs to build a second tailing storage facility. So on their laptop or their computer back in the office, they open up Emlid Flow on their website, Emlid Flow 360. They create a project. They set the coordinate system, and then they can literally drag and drop the DXF data into that project. And as soon as they drag and drop information into the project, it's synchronizing in real time with the user in the field. So whoever it is who's out in the field will see the project pop up in the list of projects, and they'll see that data pop up in the project as well. So in this screen grab of the phone on the right-hand side, we don't just have the design strings for the project, but we've got a three-dimensional surface underneath it. And in that way, the elevation can come from the surface, and the alignment for the horizontal alignment for the strings can come from the strings themselves, where that's relevant. So here's the guy in the field. We've sent one of our earth moving operators out to stake out the embankment of the tailing storage facility. And you can see the rover down here. And this is what the guy in the office is seeing. So in real time, it's showing up all of the staked marks, effectively like real-time point-by-point stakeout report. And he can look at the deltas, but he can also see that this guy in the field is actually staking out the toe of the embankment. And the toe of the embankment is where the embankment, which is going to be, a fixed grade at a design, basically meets the landscape. So it's kind of going to be a result of the grade of the embankment more than going, this is where the rock has to stop right here. And what the project manager really wants is for the guy to be staking out the top of the embankment, which is the line off to the left of the line that has all these staked observation points on it. So he can see this happening in real time, and he can ring the guy in the field and go, hey, Charles, you're staking out the toe of the embankment, and that's great, but what we really need is for you to stake out the alignment of the top of the embankment. Can you just go back and start staking that out? And so Charles then goes back and starts staking out the other alignment, And if we look at that, this is a bit of an artificial photo, but to help make the point, this is the line that we're asking Charles to stake out. This is now overlaid on an image of this site after the embankment was actually constructed. This is a real world project. But you can see how what we've been able to do is to very quickly arrest an error in stakeout and help maintain productivity on site with the support from the office in real time. What I'd like to do now is throw the mic over to Philip Wilson from Trilogy Consulting. Philip's an environmental scientist with Trilogy Consulting, and we introduced those guys a little earlier on. And Philip, I'll invite you to unmute yourself and share some of your own experiences with Emlid with us. Thank you.
Yeah, thanks, Alistair. So as mentioned, Phil Wilson here from Trilogy Consulting. We're an Adelaide-based environmental and geotechnical consultancy, and we work most closely with developers, contractors to try and provide practical, cost-effective environmental and geotechnical solutions. So being an environmental consultant and geotechnical consultant, our surveying needs are usually modest, but we need dependable spatial information, which Emlid has filled that gap as a business really well. It was initially purchased to support drone operations, but as we become more familiar with the Emlid product, it quickly provided valuable in other parts of the business as well. The biggest gain has been confidence in our data. We can plan work, understand constraints, and communicate outcomes with much stronger positional basis. One of the clearest benefits has been on-site planning for us. On a recent project, we loaded the site drawings into Emlid and could see the site boundaries and work constraints in real time. This let us discuss restrictions on site without needing prior pegging out or separate surveys to support. Example of the above plan that you can see on that top end there. This was a high-level waste management site and saved a small developer approximately $80,000 just in disposal fees alone. The same applies to service locating, and once service plans are spatially referenced, we can return to those points even after physical markings have faded, which proves safety and reduces uncertainty during excavation and intrusive works. Emlid has also strengthened our GIS workflow. The same platform that supported drone operations now help connect field capture with reporting for waste classifications and similar investigations. Sampling points can now be recorded with much higher confidence rather than being approximate dots on a plan. When those outputs are linked into ArcGIS, site figures can be prepared quickly and often very limitable manual adjustment. That improves both efficiency and the quality of a final deliverable. Another strong case is for us with groundwater monitoring wells. On older, more complex sites, wells can become overgrown, buried, or effectively lost. By loading the pre-existing survey data into Emlid, we were able to locate the full well network much more quickly with greater confidence. Also, it helped us identify which wells were likely to be affected during future development work so they could be proactively decommissioned, avoiding unnecessary costs and reducing risk and project delays. Taken together, these examples show the practical business value for Emlid in Trilogy. It supports planning, locating, field capture, and client communications as one connected workflow. That means higher confidence in day-to-day work, better efficiency in the field, and safe decisions around services, infrastructure, and cleaner reporting outputs for clients.
Thanks, Philip.
Contact details there if you feel free to reach out.
That's great. Yeah, thanks so much, mate. Look, it's some really powerful examples there of how, the simplicity and affordability of Emlid's solution allows, your operation to keep moving without having to engage a professional surveyor to do those tasks, but to still deliver the accuracy that you need to find and relocate features. So, just reflecting on those professional surveyors, so where do in-house GNSS measurements end and surveyors remain essential? Obviously, it's great that we have this capability to leverage GNSS to keep sites moving and to have it so technically like user experience simplicity and financially affordable for non-surveyors to be able to engage with the technology. But it's really important to emphasize that there are some areas of our economy that are regulated, and that includes things like legal boundary surveys. So anything to do with, marks that define legal boundaries, from a legal perspective, shouldn't be interfered with by people that aren't registered cadastral surveyors. And of course, professional surveyors are also really helpful for more complex high value tasks, such as establishing control networks and site calibration, doing high risk and high tolerance work, and ensuring that regulatory and contractual sign-offs are appropriately and defendably assessed and reported. So the most successful projects and the most successful customers are those that define this boundary between the stuff that DIY surveying can do and the stuff that needs professional surveyors, so we can keep them focused on areas where their expertise has the greatest impact. So with that said, let's take a look at the ROI. So if you've got a contract surveyor, and we heard some figures from under 20,000 to more than 40,000, and depending on how much you're using a contract surveyor, that cost can extend to $100,000 a year pretty easily. So an Emlid RTK setup starts at under 5K, and that's a potential saving of at least 70 to 80% and an investment that pays for itself in under 3 months. So in those, when you take that into account, the ROI is pretty compelling. This is another contractor, so earth-moving contractor, Coleman Contracting. And there's a video, but unfortunately the earth-moving equipment operating in the background kind of drowns Tom out. But basically he says the service is great at Mango's mapping and the products sell themselves. So another happy customer there. Finally, we want to invite people that have participated in this webinar to take advantage of some of our offers. So there is a free 30-day trial that you can access for Emlid Flow Pro if you'd like to try some of the more advanced features like surface stakeout. And we are also happy to put some time into any of our viewers today to chat with you about where things are at in your business and where they might like to go in the future, and perhaps to demystify things in a private forum, so you don't have to ask all of those hairy technical questions in the Q&A today. But if you'd like to have one of our team work with you on a one-on-one basis and go through where you're at and where you'd like to be and what those gaps might look like, we're happy to spend that time with you. And we do have Emlid survey gear that we can loan out to people to give them the opportunity to trial Emlid as well. So we invite you to take advantage of that. I'll take just a moment to introduce our sales and support team. So in sales, we've got Brad and Jamie Lees, and they're the people that understand how this stuff hangs together and where the gaps are between what you've got and what you need to get where you want to be. And support are the people that are going to help you once you've bought the gear. They're going to help you make sure that what you've bought is doing the job for you and help you troubleshoot any issues that you've got. So we offer free email support, and we generally respond to inquiries in 1 to 2 business days. MapGear is our online e-commerce site. If you ever want to know any pricing, you don't want to speak to a salesperson, that's completely fine. Jump onto the MapGear website, mapgear.com.au, and you can check out all your live pricing there. Thanks so much, everyone, for taking the time to join us today.